Exponential and logarithmic functions properties. So the focus of this video will be on what happens when we have a function and its inverse and we compose them. So we're going to consider our function f of x equal b to the x and its inverse log base b of x. So recall, if you have a function composed with its inverse, whatever your input is becomes the output. So f composed with f inverse of x with an input of x has an output of x. And remember, this notation right here is just another way of actually performing the composition. And also, if you have f inverse composed with f, if the input is x, the output is x. And here's the way we actually perform the composition. So let's talk a little bit about why this is true. We've named f of x b to the x, and f inverse is log base b of x. Didn't really matter which one we chose, and we're just going to compose them. I just happened to pick f of x equal b to the x. It's my first choice. So if we're going to compose these functions, we have f composed with f inverse with an input of x. Well, we know that this can be rewritten in this method here. So this is f of f inverse of x. Okay, so now we're going to replace this f inverse of x with the function. So this is f of log base b of x. So we're replacing this, like I said, with this. And then now you see that f has an input of log base b of x. So instead of f of x, we have log base b of x. So we're going to replace every x we see up here with log base b of x. So we get b to my new x. Well, the new x is log base b of x. Does that make sense? So that's what happens when you take f composed with f inverse with an input of x. You get this. So we've composed b to the x and log base b of x. But let's back up a step. We know that since these guys are inverses, whatever my input is also the output. So we see that x, and all these are equal signs, equals b to the log base b of x. So this is a composition of a function and its inverse. B to the log base b of x, the input is x, the output is x. So we put that here. Let's do the other one. So now we're going to do f inverse composed with f of x. Well, that's f inverse of f of x. Now we are replacing the input of f inverse, replacing that x with f of x. But we know f of x is b to the x. And that's from this piece right here, how we defined our function. So if f inverse of b to the x is what we're trying to find next, we know that when we have an input of f inverse, it becomes the operand of log base b. So this is log base b of x, but our x is now b to the x. So we write this as log base b of the new x, which is b to the x. Here we have a function composed with its inverse. The input is x, that means the output is x. So we see that x equals all these equal signs, log base b of b to the x. So when you compose this function with its inverse, you do get x. The input here was x, the output is x. So we know log base b of b to the x is just x. So whatever this input is, it's the same as the output. Okay, let's try some examples. And notice I've written this, this property here a little more generically. Instead of b to the log base b with an input of x, it really could be anything. I've represented it with star. But the purpose here, the thing I wanted you to really focus on, is that whatever I put right here as this input, it's also going to be the output. It's going to be the same. Because these are inverses. You have b to the x and you're composing with log base b of x. Okay, and likewise over here. Log base b of b to something is equal to the something. Whatever this input is, That will be your output. Now the kicker here is that all the bases must be the same. So let's try some. Log base 2 of 2 to the x. What's the base of the logarithm? Well, the base of the logarithm is 2. What's the base of the exponential? It's also 2. Okay, so I'm actually looking at this example right here. See that? I have a log of an exponential, a log of an exponential. So do you see if these bases are the same? I just get that power as my answer. So my answer is just x. So let's do the next example. I have 2 to the log base 2 of x. That looks more like this one. What's the base? Well, the base here is 2. Okay, same as this base. But now we're going to see, well, okay, if they have the same base, an exponential and a logarithm are inverse processes. If they have the same base, whatever my input is will be the output. So what was this thing operating on? Well, the input was x, so the output's going to be x. Look at C. Log base 11 of 11 to a power, 11 to the 8x. So let's check the base. The base of the logarithm is 11. The base of the exponential is 11. I'm looking at this example now, this case. So my input will be the output. Starting to get it? Does this make sense? Let's do some more. Here we have 6 to the log base 6 of 5m. Base of the exponential is the same as the base of the logarithm. So we have a function composed with its inverse. That means the input will be the output. So 6 to the log base 6 of 5m equals 5m. So we have log base 5 of 5 to the 13x cubed. So what's our answer? Same color I've been using. 13x cubed. Look at F. Log base 56 of 56 to the 3x squared. Bases are the same. So the answer is just 3x squared. Look at G. We have 101 to a power. So the base is 101 of this exponential. We have log base 101 of 5p. The base of the exponential is the same as the base of the log. So our answer is what the log is operating on, which is 5p. It's moving right along. 12 to the log base 12 of y. The base of the exponential is the same as the base of the logarithm. So the answer is what the logarithm operates on, which is y. Look at I. 10. Uh-oh. That log doesn't have a base. What base are we supposed to use if our logarithm doesn't have a base? So recall, if we have log x, that's the same as log base 10 of x. So if there's a base that's not written, we know the base is at 10. So now let's check it. Exponential has base 10. Logarithm also has base 10. So our answer is what the logarithm is operating on, right? So just 87. Let's do some more. ln of e to the 14x to the 4th. Again, if we have ln, we know the base already. So you have ln of x, that's the same as log base e of x. So there's an understood little e right here. So the base of the logarithm is the same as the base of the exponential. So whatever the exponential operates on is your answer. So this is 14x to the 4th. Okay, look at k. We have e to the ln r. Again, there's an understood base of e right there. So your answer is just r. For this one, we have log. Again, there's no base, so we know the base is 10. Log base 10 of 10 to the 4x. The answer is 4x. Hopefully this is starting to make sense and a whole lot of fun. So m, log base 4 of 4 to the 25p, base of the exponential and the logarithm are the same, so the answer is 25p. Part n. 19 to the log base 19, bases are the same, so we get whatever the logarithm operates on, 365 x to the 54. Look at O, log base 21 of 21 to some power. Bases are the same, so the answer is the power, right? 84x cubed plus 6. What about P? ln of e to the 55 e to the 7th. What is the base of ln? It's also e. So again, we see the bases are the same, so we get the power as our answer. Let's look at Q. 2/3 to the log base 2/3 of 5m. Base of the exponential, base of the logarithm are the same, so the answer is 5m. And R. E to the ln of 100x to the 7th. Remember, there's a little e right here as the base, so the base of the exponential and the base of the logarithm are the same, so our answer is 100x to the 7th.